Good morning, guys. Anjani Kumar here, dealing power system 2 for third year electrical students. Alright, so in the last session, we discussed about the effect of wind and ice loading on a transmission line. Right, how the weight will be changed, what is a vertical sag, what is a slant sag. So that's what we discussed. Actually, what is the formula for? So this is a wind force that is acting on the conductor, which is vertical direction, right? Always wind force is on the vertical direction, and whatever the force that is acting on a conductor due to ice, that will be in a downwards direction, right? So what is that value? Weight of the conductor plus weight of the ice, right? So the resultant will give the total weight of the conductor, right? So it will make an angle, right? So what is that angle? So tan theta is equal to weight of the W plus Wi. So this is the angle the conductor starts moving when wind force acting on the system, right? The sag starts moving. So that type of sag we can call it as a slant sag. Slant sag. So what is the net weight of the conductor? Wt is equal to square root of W plus Wi whole square plus Ww whole square. So this is the weight of the conductor plus weight of the ice forcing on the downward direction. Vertical, that means vertical direction low, you have wind force. So that is the wind force in a vertical direction. So net weight of the conductor Wt. So now how you can calculate the sag? So sag, you know the formula Wt L square by 2T, right? So calculate the Wt, you know the L value, you know the tension value, calculate the sag. So this sag we can call it as a slant sag. So if they given or not given, you just think it up that sag is a slant sag, right? And they'll calculate, they'll ask about vertical sag. So what is a vertical sag? That means sag twisting moment is there, na? You know, moment when wind force acting, and this is the sag starts moving, right? Right. So what is that slant sag? How you can calculate the slant sag means that is equal to S into cos theta. So that means a vertical sag. So you can call it as a vertical sag. So these are the things we discussed here. S into cos theta. You know the theta. How you can calculate the theta? Theta is equal to tan inverse of WW by W plus Wi. You know the value of S. Wt L square by 2T. So calculate the slant sag, calculate the theta, and find out and substitute here. You will get the find out the theta, find out the slant sag, substitute here, you will get the vertical sag. So these are the formulas that we derived in the last session, right? Or else, and one more another formulas that we discussed about. So what is the W? W is nothing but weight of the conductor. Right, weight of the conductor means if directly given, you can take it as a weight of the conductor. If they given the density or a specific gravity, you have to calculate the density into volume of a conductor. So this is one more formula that we derived. So weight of the ice means same. If directly they given weight of the ice, no problem, you will directly take it. Or else they will give the density of ice into volume. Right, ice volume రావాలంటే ఏం చేయాలి? Total conductor volume. So this is the conductor na. So this is the ice na. Right, this is the ice. Total volume నుంచి conductor volume తీసేసామనుకో, you will get the ice volume of ice. Right, what is the density? You know the density. They will give the density. If you solve, we derived in the last session. So what is the formula? Pi t into d plus t. So this is the formula that we derived. And one more formula, what is the wind force? So what is the wind force? Wind pressure into projected area. Right? You know the wind force, they will give the wind force. So what is the projected area? Projected area is nothing but a rectangular shape. But suppose this is a conductor na. when wind is acting on the system, so that there will be a motion. There will be a motion. So due to the motion will be in a rectangular direction. So this is a projected rectangular shape. So this we can call it as a projected area. Right? So what is the projected area from a rectangular shape? D plus 2t into 1. That means per unit. Already. So these are the formulas that we discussed already in the last session. Right? So what is the formula? You have to find out W, weight of the. You have to find out the W. W is nothing but weight of the conductor. After that, you have to find out how much ice loading. So Wi. So this is the formula: density into pi t into d plus t. Always they'll give the tricky problems only. Directly they won't give the weight of the ice is like this, as the weight of the conductor is like this, weight of the wind pressure is like, they won't directly give. So you have to calculate that weight separately. Right? So what is W is nothing but weight of the conductor, Wi is nothing but weight of the ice. So what is the formula? Pi t into d plus t. So what is W? Wind pressure and projected area. So what is that projected area? This is the projected area. So what is the projected area? D plus 2t. Alright. So these are the formulas that we derived in a last session. Alright. Now we'll do some problems. We'll do some problems on this wind and ice loading. So with that we'll finish the sag and tension calculations. Right? I hope it's clear. So if you have any doubts, feel free to call me. Right? So this is the brief lecture on wind and ice loading. This is nothing but reminding. Right? Now we'll do one problem. First I'll write the problem. So what is the problem? Example 1. Right? A 132 kV transmission line having the following details. First, so weight of the conductor is equal to 680 kg per kilometer, right? And the second one is, so ultimate strength is equal to 3100 kg. And the third one they given length of the span is equal to 260 meters. And the fourth one given safety factor is equal to 2. Now calculate sag value. Right. First you have to observe so what they given and what you are going to define. Alright. So they given 132 kV transmission line having the following details. So weight of the conductor is given. So W value is given. So what is that value? Weight of the conductor. So weight of the conductor. So what is the weight of the conductor? 680 kg per kilometer. But you have to specify weight of the conductor per meter length. Per unit length, right? So unit ఏంటి ఇక్కడ కిలోమీటర్ కాదు కదా. సో యూనిట్ ఏం తీసుకోవాలా? 1 యూనిట్. సో మీటర్ లెంత్ తీసుకోవాలా. సో దట్ మీన్స్ 680 by 1000 you have to specify. So what is that value? 0.68 kgs. Why we are taking means weight of the conductor, always we will take it as a per unit length, right? per unit, 1 unit length. So conductor long line, so definitely you won't directly calculate throughout the length. So you have to specify per unit value. That means per unit you have to calculate. So the weight of the conductor per unit means here 1 kilometer is there. You have to specify per meter. 1 unit means kilometer, 1 unit and a meter, right? So 0.68 kg is given. After that, length of the span. So what is the length? L is given. So what is the L? 260 meters. Okay, this is also specified in meters, no problem, right? Now they want to calculate the sag value. So what is the formula for sag? WL square by 2T. Right? You know the value of W, you know the value of L, you don't know the value of T. So for this, they have given ultimate strength by safety factor is given. So now you have to note it down the formula. So tension is equal to ultimate strength by safety factor. So this is important note, you have to note it down, right? So what is the tension? What is the one more formula for tension is ultimate strength by safety factor. So from this you will calculate the tension value. So what is the tension here? Tension here, so ultimate strength. So what is the strength? 3100 kg by what is the safety factor? 2. So what is that value? 1550 kg. Right. You know the tension value, you know the weight of the conductor value, you know the length value. You have to substitute. You will get the sag value. So what is that sag value? So what is the sag value? S is equal to, what is the weight of the conductor per unit? 6.68 kg into, what is the length? 260 m. Na? That means 260 whole square by 2 into, what is the T? 1550. So if you calculate it, you will get 3.7 meters. So that what is the sag value? Sag value is a 3.7 meters. In this way, they will ask the questions, right? See what they given and what he is asking means 132 kV transmission line having a weight of the conductor and a length of the span length is given, and directly he won't given the directly tension value. He has given ultimate strength and the safety factor. So with that you have to calculate the tension value, how much tension present on the system. So with that you have calculate the sag value. So weight of the conductor per unit length, but 680 kg per kilometer length. But you have to take per unit. That means 1 meter length, 680 by 1000. You will get the 0.68 value. So L value means what is the span? 260. How you can calculate the tension? Ultimate strength by safety factor. If you apply it directly, you will get the tension. So what is the tension value? WL square by 2T. You got the tension value 1550. You know the W value. You know the L value. You know the T value. So what is the sag value? 0.68 into 260 whole square by 2 into 1550. So we can calculate the sag is 3.7 meters. Now we'll go for another problem. Right? Now I'll note the problem. So this is somewhat tricky. Right? A transmission line has a span of 150 meters. Right? Now the conductor cross-sectional area cross-sectional area 2 centimeters square. See what you just directly understand what he is giving. So conductor span is given, the conductor's cross-sectional area is given. The tension of the conductor is given 2000 kV. So tension is given. if the specific gravity of the conductor material, right, specific gravity is given, is 9.9 gram per centimeter square. So units are also important, but we need to concentrate, right? So after that, they given, and wind pressure is given. Wind pressure. So what is that wind pressure? 1.5 kg per meter length. So they given per unit length is also. Calculate the sag and vertical sag. Calculate sag and vertical sag. Right? First you have to study the problem, right? The transmission line having a span of 150 meters. So what is the length is given? Length is equal to 150 meters. Right? So the conductor cross-sectional area is given. So what is the conductor cross-sectional area? Means weight. So whatever this is, first you have to note it down. Conductor cross-sectional area 2 centimeters square. Right? Now the tension is given. So what is the tension? 2000 kg. Specific gravity is given. Specific gravity is given as 9.9 gram per centimeter square. Right? So wind pressure is given. WW is given 1.5 kg per meter length. Calculate the sag and vertical sag. So vertical sag is equal to S into cos theta. If you know S, you can easily calculate S cos theta. So these are the items they given. First understand, is there any ice loading? There is no ice loading. Only wind pressure is going to be present in the system. So we'll see. So wind pressure working on this direction, and in this direction only the weight of the conductor. There is no wind pressure. There is no ice loading. So what is the angle? What is the resultant net weight? So WT. So what is the WT? You have to calculate W plus W square plus WW square. If you find the WT, you can easily calculate the sag. So what is the formula for sag? WT L square by 2T. Substitute here, you will get the sag. After that, you substitute here, you will get the theta. From that, so what is the theta? Tan inverse WW by W plus W. You don't have any WI, so tan inverse WW by only W. So this is the formula for theta. You know the theta, you know the S value, calculate the vertical sag. Right? Now we'll solve the problem. Right? First, you have to calculate WT. So what is WW? Is directly given now. So what is WW? 1.5 kg per meter. So okay, WW over. Now you have to calculate the weight of the conductor. So what is the weight of the conductor? What is the formula for weight of the conductor? Density into volumes. That's why I said earlier. So they won't directly give the weight of the conductor, weight of the ice loading, weight of the wind pressure. They won't directly give. If they will directly give, it doesn't have any problem. They don't have any difficulties to finding the values. So the density into volume per unit length. Right? So what is the density? Density is nothing but specific gravity. So how much specific gravity is given? So specific gravity is 9.9 gram per centimeters. So gram per centimeter cube. So right, gram per centimeter cube into what is the volume? Right. So what is the volume per unit length? So what is the volume is given? So conductor cross-sectional area. So he given a conductor cross-sectional area is given. So that is nothing but the volume, na. So what is the cross-sectional area given? 2 centimeter square. 2 into centimeter square. Alright, this can cancel. Alright, and this is for 1 meter length. So into 100. All are in centimeters, na. That's why I have to put 100 over here. Alright, so what is the value? If you calculate it, you will get to 1.98 kg. Right, this is nothing but specific gravity. Density is nothing but specific gravity. Volume per unit length. Right, per unit length is, what is the length? Meters, na. Per unit length. So meters, all are in centimeters that you are calculated. That's why you put 100 over there. Alright, so 9.9 into volume రావాలంటే given a cross sectional area. Cross sectional area is given. So what is the volume? 2 into centimeters, right? 2 into 100. So what is the value? 1.98 kg. So weight of the conductor is, you got it. Now you calculate what is the total weight. So square root of 1.5, all are kgs na, no problem. 1.5 whole square plus 1.98 whole square, right? If you make this, you will get 2.48 kgs. I think you understand. So what is the W is always already given. What is the weight means? Specific gravity is nothing but density. So volume is nothing but 2 is given a cross sectional area. Alright, so you got the 2.48 kgs. You know the net weight also. Then what he is asking? He is asking what is a slant sag. So what is a sag value? What is the formula for sag? WT square by 2T. You know the WT 2.48, that is equal to. And so what is the L value? Length 150 meters. 150 square by 2 into what is the tension given? 2000 kgs. Right? If you substitute, you will get the answer is 3.48 meters. So okay, sag is over. So you calculated the sag value. After that, what they are asking, what is a slant, what is a vertical sag? So what is the formula for vertical sag? Right? So what is the formula for vertical sag? So vertical sag is equal to S into cos theta. So you don't know theta value. So what is the theta? Theta value tan inverse of W by W. W I ledu. So that's why you have to neglect. Theta is equal to tan inverse of what is W? So what is the W? W is nothing but 1.5 by what is the W value? 1.98. Right? So if you calculate it, you will get the theta value 37.23. Right? You know the theta value. You know the S value. S value is equal to 3.48 meters. Then directly substitute. So what is vertical sag? Is equal to S into cos theta. So what is S? 3.48 into what is cos theta? Cos of 37.23. So if you do this, you will get the result at 2.77 meters of vertical sag. Right? So in this way you have to calculate. First understand these what is the steps are. It's not that much important, right? You have to understand what he is given and what he wants to find out. So that's you have to understand, right? I'll explain one more time. If the transmission line span is given, length is given, the conductor cross sectional area is given. So the conductor cross sectional area is given, right? Specific gravity is given, tension is given, right? Wind pressure is given. Then calculate the value of sag and vertical sag. So what is the formula for sag? WT into L square by 2T. So they only wind pressure only acting on this conductor. So wind pressure always in a vertical direction. Along horizontal direction, you don't have an ice loading. Only wind pressure is present in the system. That's why I have taken only W. So what is the net weight of this one? W plus WW whole square. So from this, how much angle the sag is going to be created means theta is equal to tan inverse of WW by W plus W, actually formula. But you don't have a WI. So that's why you should make it as theta is equal to tan inverse of WW by W. Got it now? So you find out the theta value. So after that, first you have to find out the WT. So sag calculate cheyalante, you should require WT, L and TT. You know the L value, you know the T value. So you have to calculate WT. So what is the formula for WT? W plus WW whole square. So what is the WW? They directly given that 1.5 kg per meter. So what is the W? They won't directly give. They give the specific gravity and cross sectional area. So with that you have to substitute specific gravity into volume. Right? So with that you will directly get the W value. So after that you have to calculate WT. So from this you calculate the WT like this. Then find out the sag value. So the sag value, if you calculate the sag, WT into L square by 2T. That is, if you substitute here, you will get a 2.48 then you will get 3.48 meters. So okay, sag is over. Then what he is asking, he is asking vertical sag also. So what is the formula for vertical sag? So vertical sag is equal to S cos theta. So first you have to find out the theta value. So tan inverse of W by W. So when theta is calculated, then find, you know, the sag value. Then substitute here, you will get the vertical sag value. S into cos theta. If this is S value, this is cos theta value. Then find out the vertical sag. So in this way, they will ask a typical question like this. Right? Right? Now we'll go for another problem. I don't want to another problem which is having ice loading on the system. So I don't want to take all the statements. I just want to write what they given, what they are asking. That's it, right? So this is a very, very important problem, right? So the problem is very lengthy, so it's not that much effort to write all the problems, right? I just want to write what they given, and we should find out sag value, all these things, right? So first, what they given, I'll write it here. Example 3, right? They given the length of the conductor. Length is given. So what is the length value? 275 meters, right? So after that, they given conductor diameter. So that means a D value is given. So what is the value of D? 1.96 centimeters, right? So the parameters is nothing. So after that, so they give in conductor, weight of the conductor per meter length. What is that value? 0.865 kg. So weight of the conductor is given. So W is given, right? Ice coating thickness is given. So ice coating thickness. So what is the T value? So what is the T? 1.27 centimeters, right? Ice coating thickness, D is given, T is given, and length is given, all right? And after that, they given ultimate strength. So ultimate strength is given. Is giving means you need to find out the tension value yourself, right? So what is the ultimate strength? So that is equal to 8060 kg, and given safety factor, right? So what is that safety factor? 2. From that you will calculate the tension. No need to give that tension value, right? So these are the things they given, right? And after that, weight of ice. Right. So these are the things they have given, and find out the sag value. Right? Find out the sag value. First you have to draw the figure. So which is having both wind force and ice loading on the system. So what is the wind force in this direction? Right? Ice loading is W plus Wi in this direction, right? So this is the total net weight. So you have to calculate the net weight. So what is the formula for net weight? Square root of W plus Wi whole square plus WW whole square. If you calculate this wind force, what is the sag value? WT L square by 2T. So from this, first you have to calculate the tension value for this. So what is the tension? Ultimate strength by safety factor, 8060 by 2. So from this you will get the tension value 4030. So 1T is over. You know the length is over. So T tells you. What is the length value? L is equal to 75 meters. L is tells you. Now you have to calculate WT. This is very, very tough question. So you have to calculate WT. So WT and you have to WW is there, WI is there, WW is there. So for this, first you will get the W value. So weight of the conductor, right? So directly they give. So weight of the conductor per unit length. So 0.865. So weight of the conductor also over. Then you have to calculate WI. So what is the formula for WI? So density into pi T into D plus T. So you already into per unit length, 1 meter length, whatever it may be. So the density is nothing but specific gravity is given now. Right? So what is the specific gravity? 0.91 is a specific gravity. So already given. So given in the figure itself. I didn't write there. So given as specific gravity into pi. What is the thickness? Thickness is given. So 1.27. So what is the diameter? D. D is given 1.96. Right? So you have to calculate centimeters to meters, whatever it may be. All these things you have to do. This is a mathematical approach. I don't want to tell all this information, right? So what is the t value? 1.27 into 1. Right? If you solve, what is how much you'll get? You'll get the weight of the ice is 1.172. Okay, weight of ice is also, you got the weight of ice also. Right? So after that you have to calculate weight of wind. So what is the formula for weight of wind? Wind force is given. Force into projected area. Right? Force also given. So what is the force value? 3.9. Also given. I forgot to draw this one. So force also given. 3.9 into projected area d plus 2t into 1. Substitute here. 3.9 into what is the d value? What is the d value? Diameter 1.96 plus 2 into 1.27 into 1. Calculated. You will get the result of W and the. So you will get 1.755 kg. So you know the W value, you know Wi value, WW value. So directly substitute. You will get the result. So what is this? What is the value? WT value. WT is equal to square root of. What is the W value? 0.865. Plus what is the Wi value? What is the Wi value? 1.72 whole square plus WW wind force 1.755 whole square. Right? What is the net weight? 2.688 kgs you will get. So from that you will calculate the sag value. So what is the sag value? Formula for sag. So 2.688 into L value. You know the L value 275 given. So you got the tension value 2 into 4030. So from this you will get the sag. So whatever it may be, the sag value. So this is the one type of problems if they ask when ice loading present on the system, right? So from this you will calculate the sag value 6.3 meters. So this way you have to calculate when ice loading is present in the system, right? So wind force is, you have to calculate WW. For this is the formula density into pressure, force into pressure, projected area. So that means force into d plus 2t. So what is the WW? WW directly given. You have to find out Wi. What is the formula? Density into pi into t into d plus t. All the formulas we described. From that you have to calculate WT. So substitute from that you know the WT, you know the L value. From this you will get the tension value. Substitute here, you will get the sag value. If they ask a slant sag, we have the vertical sag S into cos theta. So what is the theta value? Tan inverse of WW by W plus Wi. Theta value find out change S, you know the S value. Cos theta substitute just you will get vertical sag. Right? In this way you have to find out these type of questions are very very important. So the problem is very lengthy, that's why I didn't write the problem over here. So what are the things they'll given? I just write it down and solve the problem, right? So with this we finish the concepts of sag and tension, right? In the next session we'll discuss about the insulators concept. So thank you for now.